First, see what are the products of the combustion reactions of hydrocarbon? Gayatri, hydrocarbon combustion products. Pritika, CO2 and H2O. There, yes. You can combust any hydrocarbon, methane, ethane, propane, benzene. Then you will get the CO2 and H2O. Combustion products are CO2 and H2O. Methane, CH4 plus O2 combustion. Burning in the presence of oxygen gives rise to CO2 and plus H2O. See, these are common. CO2 and H2O are common. Ethane, ethylene, acetylene, any hydrocarbon gives CO2 and H2O. What is the question? When we combust 1 mole of methane in the presence of air, how many moles of CO2 is produced? How to do? Balance the equation. If we balance, then we'll get coefficients. That coefficients only represent moles. Okay? Alright. How many carbons are there? 1 carbon. Here also 1 carbon. Balanced. How many hydrogens are there? 4. Keep 2 here. 2. This side, how many oxygens are there?
4.
How many oxygens are there? 4. 2 into 1. 2. Here 2. 4 oxygens. 4 oxygens. So here we have to keep 2. Okay. Moles can be written based on the coefficients. 1 mole. Your coefficient is 1. Here also 1 mole. 1 mole. So 1 mole of methane gives 1 mole of CO2. Mole relation. Mole relation. First we should write balanced equation. Then we'll get perfect moles, correct moles. See, to do any question, weight question, weight volume question, first we should write the moles. How to write the moles? If you know how to balance. Can you do balancing of another acetylene? Try for acetylene, all of you. Make it fast. Tell me moles of CO2 and water. Next question. Second question. Acetylene C2H2 plus O2 gives rise to CO2 plus H2. Tell me moles of water and CO2 produced on. See, 2 carbons are present on the left side, so right side 2 carbons. How many hydrogens are present? 2. Here also 2. Hydrogens are balanced. How many oxygens are present on the right side?
5.
We have to imagine the bracket. 2 into 2, 4. 4 plus 1, 5. This side 5 oxygens are there. Then how to write 5 oxygens here? 5 by 2. 5 by 2. 5 by 2. Because 2 will get cancelled, 5 will remain. 5 will remain. So what are total moles? This is 1 mole. 5 by 2 means 2.5 mole. This is 2 mole. And this is 1 mole. Mole relation. Next, weight relations or weight calculations. Weight calculations. Second one, weight calculations. Or weight relation, both are same. Weight calculation or weight relation. See, in weight calculations, how we will get the question? What is the weight of CO2 produced when 50 grams of limestone is combusted? Or how much weight of CaCO3 should be heated to get 0.4 grams of CO2? 2 substances data will be given in terms of weights only. Okay, weight relation. Take this example, same example, methane plus O2 gives rise to CO2 plus H2O. Balanced equation 2 here and 2 to 4 to here, right? Let us take methane and the CO2. We can write moles for all reactants and all products, but take only one reactant and one product. This is 1 mole. See, in order to do question based on weight or weight volume, first we should write mole relation. That is important. Okay, write mole relation after balancing. 1 mole and CO2 also 1 mole. See, weight. What is weight of 1 mole of methane? 1 mole of methane weight.
16.
Weight of 1 mole of online students. Weight of 1 mole of any substance is equal to its gram molecular weight. 16 grams. 16 grams of methane will give 1 mole of CO2 weight. weight of 1 mole of carbon dioxide. Its molecular weight, gram molecular weight. Say its gram molecular weight, 44 grams. So this is weight relation. For 16 grams, always how many grams of carbon dioxide is produced? 44. Weight. For 16 grams, 44. For 8 grams, 22. Weight relation. For 4 grams, 11. Weight relation. What is standard relation? For 16 grams, always will get a 44. That is weight relation. Clear? Note down. 16 grams of methane upon combustion produce 44 grams of carbon dioxide. That is the meaning. Next, weight volume calculation. Means one substance data is present in terms of weight, other substance data is in terms of volume. Weight volume. Third one, weight volume. Weight volume relation or weight volume calculations. C2H6 plus O2 gives rise to CO2 plus H2O. Balance this entire. First write moles relation. C2H6 name is Sweta. Because we will get the names also: methane, ethane, ethylene. Mole relation. How many carbons are present on the left side? Online students. 2. So right side 2. Hydrogens are 6. So here we have to write a 3. Then calculate oxygens on the left side, the right side. So 3 oxygens here. 4. Total how many? 7. And how to write 7 here? Is it possible? Fraction 7 by 2. 7 by 2. 7 by 2 means 3.5 moles. 3.5 moles. So 1 mole, 7 by 2, 3.5 mole gives rise to carbon dioxide is how many moles? 2 moles of carbon dioxide. Right. Heading is weight volume. Now say its weight, 1 mole of ethane. Say its gram molecular weight. Calculate. Carbon is 12 atomic weight. 24 plus 6, 30 grams. 30 grams of ethane produce how much volume of CO2? 2 moles means volume. What is the volume of 1 mole of any gas at STP? 22.4 liter. For 1 mole, for 2 moles, 44.8 liter. 44.8 liter. So this is standard relation. Weight volume. 30 grams always produce 44.8 liters. 15 grams produce half of this. That is weight volume. So first we should balance the equation. We should write proper moles. Then based on the given data, we have to take weight or volume data. %, probability is there in stoichiometry. Stoichiometry, several concepts are there, very important. Empirical formula is there, limiting reagent is there, balancing equation, oxidation states, number of atoms finding, molecules finding. All are important areas only. Okay. Next, write one general equation. Combustion reaction. General combustion reaction of HC, hydrocarbon. General combustion reaction of hydrocarbon. CXHY X plus Y by 4O2 gives rise to XCO2 plus Y by 2 H2O. You have to by heart this equation. You will ask me to see all of you. This is how many moles? Hydrocarbon is how many moles? Online student. Hydrocarbon is how many moles? In front of CXHY, 1 is present. So this is 1 mole. 1 mole of hydrocarbon upon combustion is producing how many moles of CO2? X moles of CO2. And how many moles of water? Y by 2 moles of water. For 1 mole, X mole, Y by 2 mole. Gayatri for 10 moles. 10x 10 into y by 2 mole. 10 into y by 2 mole. Do one question on this, right? Start with the difficult question on first. Okay, we will compare what can be. Note down the question. 10 ml of hydrocarbon. 10 ml of hydrocarbon upon combustion produce 40 ml CO2 and 50 ml H2O. Find formula of HC hydrocarbon. Option A C2H6, option B C4H10, C C4H8, D C5H12. 10 ml of hydrocarbon upon combustion produce 40 ml of CO2 and 50 ml of water. Find the formula of hydrocarbon. By using general formula, we can do this. First of all, write the general formula. Try to write without seeing, that gives practice. CXHY plus x plus y by 4 O2 gives rise to XCO2 plus y by 2 H2O. तो తెచ్చుకోపోయి కింద సర్వెంట్ according to standard reaction, this is 1 mole. This is x, this is y by 2, according to standard reaction. Okay, but according to the data, how many moles? See, when we get the question in which gases reactants and gases products are present, we can consider volume as moles. According to Avogadro's law, number of moles can be considered as a volume. Volume is considered as a number of moles. 10 ml means you can consider 10 moles according to Avogadro's law. Once we have gases state shorter. Okay, 10 ml means 10 mole, 50 ml means 15 mole H2O, 40 ml means I will mention that. Okay, for 1 mole x mole y by 2 mole, you tell me. For 10 mole 10x mole y by 2 into 10 mole. Okay. In case of gases, reactants and products, we can replace volume by mole by volume based on our requirement. Okay. Or you can do like this only. We can keep 10 ml only here. First of all, we have to write mole relation. That's why I wrote mole relation. Okay. 10 mole, nothing but 10 ml. I will mention that one. 10x ml y by 2 into 10 ml. So write within the brackets. According to Avogadro's law, moles can be considered as volume. According to Avogadro's law. Mole is nothing but volume in case of gases, reactants and gases products. First we wrote mole and we took that mole as volume directly. According to Avogadro we can take, because Avogadro law is related to mole and volume, number of moles and volume. Right, you tell me. Which data you know? Which data you know? So you tell me. This 10x is the volume of water. Volume of water.
40.
CO2 liberated. CO2 liberated. 10x ml is the volume of CO2 liberated. Y by 2 into 10 ml is the volume of H2O liberated. But that are given in the data. Okay. This is equal to. Oh, this is equal to 40. Equate that and find x value.
Option
And this is equal to, this total represent volume of H2O. That is given already in the question. You find out x and y values.
Option B.
Option B, yes. Ten into x is equal to 40. X is equal to 4. Next, y by 2 into 10 is equal to 50. This 0 cancelled. So formula is general formula CXHY. So C4H10 is the formula, important model. అది మీకు రీసెంట్గా వచ్చింది క్వశ్చన్. Right. Now let us come into basic level questions. ఒక టఫ్ లెవెల్ ఒక రెండు బేసిక్ లెవెల్ చూద్దాం. You know weight relation, weight volume relation. Online students, ఇది మీకు అర్థమైందా? ప్రాగ్నిక కేతురా ఫాలో అయ్యారు. కేతురా ప్రాగ్నిక యాశ్వి ప్రణయ్. In hydrocarbon combustion reactions, okay, based on CXHY numericals, consider volume as mole, mole as volume. Remember this point. Next question, very simple question. Do this. The volume of O2 required in liter. Mention in liter. The volume of O2 in liters required to combust 2.8 kg of ethylene. The volume of O2 in liters required to combust 2.8 kg of ethylene. Mole relation, 1 mole. This is 3 mole. In first we should write mole relation. Question is related to weight and volume. Correct only, na? Yes. Whose weight? Ethylene weight. Whose volume? Oxygen volume. So write ethylene weight in terms of ethylene data in terms of weight. 1 mole weight. Weight of 1 mole of ethylene. Add carbon 12 plus 12 24. 24 and 4 28. 28 grams or kg. Gram molecular weight means grams only. Grams. 28 grams. But data is in kg. Convert it into kg. 28 into 10 to the power of minus 3 kg. Okay. 3 moles means how much volume? 3 moles means how much volume? 1 mole volume is 22.4 liter. 3 moles is 3 into 22.4 liter. So what is the conclusion? 3 into 22.4 liters of oxygen is required to combust 28 into 10 power minus 3 kg of ethylene. This is data, standard data according to the equation. First we should develop this standard data. Now coming to the question. What is the question?
volume of O2
To,
in liters
to combust 2.8 kg. For 28 into 10 power minus 3, this much volume is required. For 2.8 kg, how much volume is required? Do cross multiplication. Yes. So x into 28 into 10 power minus 3 cross multiplication is equal to 2.8 into 3 into 22.4. Simplify and tell me. ఇది మీరు డైరెక్ట్గా చేయొచ్చు సింప్లిఫికేషన్. What is x value? 2.8 into 3 into 22.4 divided by, say final answer, 6720, 3720, 6720, 20. Liters are? Okay. Next, keep reading. Percent purity. Percent purity. We will do numericals. We will continue numericals after completing theory part. Percent purity. What is the meaning of percent purity? See, we purchased 100 grams of, let us consider, we purchased 100 grams of limestone. Limestone general formula is CaCO3. What is the total weight of limestone? 100 grams. So in that 100 grams, only 80 grams is pure. 80 grams is pure. Remaining this 20 grams is impurity. This is impurity total. 20 grams impurity. You tell me how much percent it is pure? 80%. That is called percent purity. We purchase some goods in the market, but that are not 100% pure. Some impurities are present. Okay, dal, sugar, oil. Okay, percent purity means how much percent it is pure in a substance is called percent purity. For percent purity, we have one formula. Percent purity is equal to weight of pure compound. Weight of pure compound divided by weight of impure compound. Whose weight is more? Tell me. Pure compound or impure compound? In this diagram, you tell me. No. This total, what is the total weight of this substance? This total substance is pure or impure? Impure. Always impure compound weight only more. Okay. In impure compound, some pure compound is present inside it. Impure compound weight will be more always. Pure compound weight is less. See, in this 100 grams, 80 grams only pure. So weight of pure compound, smaller weight by higher weight into 100. 80 by 100 into 100, 80%. 80%. Remember the formula for percent purity. This is pure, 80 grams. Total weight is 100 grams. 80 grams is pure part, 20 grams is impure part. These numericals are little bit confusion, but came in the NEET JEE also. Okay. First of all, remember the formulas. Percent purity concept is clear. Okay. Next, percent yield. Keep heading percent yield. Online students. Hello. Excuse me. Unnara meeru? Percent yield. Percent purity, percent yield. Percent yield means, see, we conducted one reaction in a laboratory. Okay. We got some weight of product. Okay. Theoretically its weight is different, practically its weight is different. 100% we won't get 100% good yield because due to impurities. Okay, starting material may be impure, apparatus may be impure. On the notes, for example, look at this. If you combust CaCO3, you will get how much weight of CO2? Tell me, how much weight of CO2? This is 1 mole, right? 1 mole, this is 1 mole. Say 1 mole of limestone weight 100 grams will produce. This is for notes only, for theoretical discussion only. Clear? But if you purchase 100 grams of limestone in the market, in the scientific traders, and if you combust that 100 grams, you won't get 44 grams. How much you will get, guess? Less than 44 or greater than 44? Less than. Why? Imagine. It may contain some impurities. They won't give pure CaCO3 for us. Some impurities will be present in it. Percent yield. Percent yield, yield nothing but amount of product. Percent yield. YIELD. Yield nothing but amount of product. Amount of product. Right? Okay, see. Theoretically, how much weight we have to get? Theoretically. This is theoretical. Theoretical yield. Theoretical yield. When we hit 100 grams of limestone, theoretically how much we should get? 44 grams. That is fixed. But you tell me, if we get 40 grams practically, that is called as actual yield. Actual yield. Actual yield. Because of impurities in the starting material or contamination of equipment or apparatus, we will get less than 44 only, always. This is actually, theoretically 44, but actually how much we are getting? 40 only. Now can you guess the formula for percent yield? Actual yield means practical data. This is practical data based on our experiment, practical data. Tell me, percent yield. Guess the formula. Percent yield is equal to actual yield by theoretical yield into 100.
ఇది అట్లా బ్లర్ అవుతుంది.
ఇప్పుడు ఓకేనా?
అది లో బ్రైట్నెస్ తక్కువ వచ్చింది.
Remember the formulas. Okay. రేపు న్యూమరికల్స్ చేద్దాం. నెక్స్ట్ హెడింగ్ మినిమం మాలిక్యులర్ వెయిట్. మినిమం మాలిక్యులర్ వెయిట్. Minimum molecular weight. Minimum molecular weight. Find minimum molecular weight. Percentage of element is equal to atomicity into atomicity into weight of element. Weight of element. This is general relation only. Weight of element by weight of compound. Weight of compound into 100. See, one simple example I will take. I am taking CO2. Sorry. Carbon dioxide. If I ask you what is the percentage of carbon in CO2, how can we do? What is the generally how you will do? I am giving CO2 to you. What is the percentage of carbon in CO2? What you will do? Carbon weight by total weight into 100. That is the formula, simple formula, very easy formula to find the percentage, right? Let us do percentage of carbon is equal to what is the weight of carbon? 12 by what is total weight? 44 into 100. This is percentage, right? 44 is the molecular weight. 44 is the molecular. But this is the original formula. Additionally, we are including atomicity. This formula we know this formula. But additionally, we are writing atomicity. Percentage of element is equal to include atomicity. Atomicity into weight of element. See, what is atomicity of carbon here? Indirectly, we followed this formula only. Indirectly. What is atomicity? How many carbon atoms are present? 1. 1 into atomic weight of carbon, 12. By total weight, 44 into 100. But why we kept hitting minimum molecular weight? Whenever you get the question, find minimum molecular weight, take atomicity as 1. That is important point. To find minimum molecular weight, take atomicity as 1. If you read all the formulas, we will do questions on all concepts at a time. Okay? Write that point. To find minimum molecular weight, take atomicity is equal to 1. Next, very important concept, limiting reagent. Keep heading, limiting reagent. Limiting reagent. Limiting reagent. How to find limiting reagent? What is a limiting reagent? What is the use of limiting reagent? I already explained this story. This is one car frame, okay, outer frame. We have 2 frames and 4 wheels. This is the data. Here we have frame, outer body part frame, and a wheel unit. Different units are there in the factory, car manufacturing factory, right? With this data, how many cars you can produce in the market? How many cars you can produce? 1 car only, because to produce 1 car we need 4 wheels. Okay, we use these 4 wheels and we fit to this, then we'll produce 1 car. Okay. In this data, which is utilizing completely and which is in the excess? Wheels and the car body part, which is utilizing completely? Wheel is utilizing completely, wheels are utilizing completely. This is excess. So this is called a limiting reagent. Similarly, in a chemical reaction, the reagent or reactant which is completely utilized is called as limiting reagent, which is completely utilized. Limiting reagent which is present after reaction is called excess reagent, but limiting reagent is important. Right? Simple definition: the reagent or reactant which is utilized completely. The reagent or reactant which is utilized completely is called limiting reagent. Reagent or reactant which is utilized completely. Procedure to find limiting reagent. Step 1, find moles. Step 2, divide mole with coefficients. Step 3, identify least mole by coefficient value. Very easy. Finding limiting reagent is very easy. First we have to write the moles, or we have to find the moles of reactants. After that, do mole by coefficient ratio. After that, see which is the least mole by coefficient value. Let us do one question, we can understand easily. Okay. Note down one question to understand this. 14 grams of N2 is combining with 32 grams of O2 to form NO. Find LR, find limiting reagent. Can you write balanced equation? Sometimes we won't get equation. Online students, మీకు కంఫర్ట్గానే ఉందా, ఫాస్ట్గా అవుతుందా ఏమన్నా? ఆల్రెడీ మనం స్టైకియోమెట్రీ మొదలుపెట్టి 3-4 డేస్ అయింది. 4 డేస్ అయిందా, 5 డేస్ అయింది. ఇంకా స్లోగా వెళ్తే ఇంకా నీట్గా ఒక 2-3 లెసన్స్ ప్రిపరేషన్ అవుతుంది మనకి. ఇది ఫాస్ట్గానే ఉంటుంది, మీకు అర్థమైనా కాకపోయినా ఇంకా వేరే చేసేది ఏం లేదు. ఇది ఫాస్ట్గానే మూవ్ అవుతాం మనం. ఈక్వేషన్ N2 + O2 gives rise to N2 plus O2 gives rise to 2NO. What is step 1? Finding the moles or writing the moles. Okay. Moles, we are writing moles. You tell me what is given for us. Weight is given for us. Weight of nitrogen is given. If you know weight, we can find the moles. What is the formula for number of moles? Weight by gram molecular weight. That is equal to how much? 0.5. 14 by 28, 1/2, 0.5. Here moles of O2, weight by 32 by what is the gram molecular weight of oxygen? 30. Oxygen 32. 1. Okay. First step is our writing moles is our. What is next step? Coefficient. Mole by coefficient. This is step 1. Mole by coefficient. What is mole? 0.5 by Sweta. What is coefficient? N2 coefficient. In front of N2, 1. Here 1. Mole is 1. 1 by again in front of O2, 1. Which is least value? 0.5 is the least value. That value represents limiting reagent. So what is limiting reagent? N2 is the limiting reagent. That minimum value represented or minimum value belongs to which reactant? That is the limiting reagent, LR. Nitrogen is limiting reagent. What is the use of limiting reagent? How questions will come on the limiting reagent? See, we completed stoichiometry related and mole concept related formulas. One more concept is there, oxidation state. That is easy only. Read the formulas, we'll start numerical part. Once I will show you. Just a second. Did you finish this?